In this practice, compare the tidal force with a gravitational force acting on a particle on an object rotating around the stars. So mass of the star is given by capital M. Mass of the object, rotating object around the star is M. And the size of this object, this is the radius of this object, is given by delta R. And the mass of the object on this object is m sub 0. Then gravitational force acting on the object with a mass of the m sub 0, F graph, is a g m sub 0 over delta r squares. So this is a constant quantity, is independent of the distance between the star and the rotating object around the stars. And tidal force is given by 3 gm m sub 0 over r cube delta r. So this F tidal is dependent on the distance. This capital R is a distance between the rotating object with a central star. So if you draw the force acting on this object as a function of R, tidal force is increasing with a decreasing distance from the stars. So this is F subtidal. On the other hand, gravitational force is a constant. Gravity is independent of the distance from a central object. When this object is in these regions, gravity is strong enough to maintain the shape of the object in a distant orbit from a central object. However, if this particle is start rotating around the central object in the close regions, then tidal force becomes stronger than the gravitational force. Then rotating object loses the material from the surface because the gravity becomes weaker than the tidal force. Then we expect this object is broken into the number of the pieces. This critical radius dividing these two situations, we call that this is Roche limit. Okay, this is the answer to this question.